Chapter 3, Part 3, Functional Groups. A functional group is a predictable pattern of atoms that behaves in a predictable manner. Functional groups are the part of molecules that undergo chemical reactions. Being able to recognize and identify functional groups allows us to name the molecule correctly, accurately predict how the molecule will behave in different reaction conditions, and also predict the physical properties of the molecule. This course is organized by functional groups. Each new chapter covers a new functional group or related set of functional groups and the chemical reactions they undergo. So learning these functional groups quickly is going to be very important to your success in organic chemistry. The first of the functional groups that we're going to learn are on this slide. Before we start talking about the functional groups, we need to talk about R notation. R notation is a way of using a variable, the letter R, as a placeholder for any potential carbon group. You will also see that in some groups I use the symbols R prime and R double prime. This is a way of indicating that these carbon groups could potentially be different. In all of the examples that I have of functional groups, if you see R, R prime, and or R double prime, those groups could be the same or they could be different. But R is just a placeholder for any potential carbon group, and in some examples, R could also be a hydrogen. I will be clear when that's the possibility though. So our first functional group that we're going to look at is the alcohol. An alcohol is when you have an sp3 hybridized carbon, so think a methyl group, ethyl group, and you have a hydroxyl group, an OH group, directly attached to it. So you may not recall this from Gen Chem, but OH has its own name. You know that OH minus as an anion is called hydroxide. When we are describing OH as part of a molecule, we use the word hydroxyl. Previously, I mentioned that when you see YL, we are talking about a piece of a molecule. So the hydroxyl group is a piece of the alcohol. And similarly, the R group, which is representing a bunch of carbons, we can call an alkyl group. You've seen alkane, alkene, alkyne. The ALK prefix means that we're looking at hydrocarbons. And again, YL means we're talking about a piece of the molecule. So an alcohol needs an alkyl group and a hydroxyl group. I've also included some information about nomenclature here, but we are not going to be naming any of these functional groups yet. So this is more for your future reference if you would like to have all that information together. The next functional group is the ether. The ether has an R group on either side of the oxygen. It's kind of a dumb joke, but I think it helps. So you have R groups on either side of the oxygen, and that is the definition of an ether. So you have to have a carbon attached to an oxygen attached to a carbon in order for a molecule to be an ether. I'm going to draw some examples of some of these as we go. So an alcohol can be something as simple as this, or it could have a bunch of carbons and then the OH group. An ether can be something symmetrical, like dimethyl ether. You can have different groups attached, or you can even have cyclic ethers. So there are a lot of possibilities for the ether. Our next functional group is the amine. An amine is a nitrogen that has one carbon or two carbons or three carbons attached to it. And again, those carbons could be the same, they could be different. But what's important is that you have a nitrogen attached to a carbon in order for it to be an amine. So an example of this first type would be something like this. The second type, you could have a methyl. Sorry about that. You could have a methyl and the nitrogen, and then an ethyl group, and you'd still have to have a hydrogen on the nitrogen. This last one, you could have three different things attached to the nitrogen, or you could have three of the same. For this next batch of functional groups, we have to introduce another piece of a molecule. This is called a carbonyl group. A carbonyl group is a carbon with a double bond to an oxygen. And this is not a functional group on its own, but it's an important piece of many functional groups, which is why it has that YL ending. And you'll see that all of the remaining functional groups that we're going to learn in this chapter have a carbonyl at the heart of them. Now, these bonds off to the side with the wiggly lines are indicating that it doesn't really matter what that carbon is attached to. This is still a carbonyl group no matter what it's attached to. The other important thing about being able to recognize carbonyls is that we can also use this term to describe pieces of the carbonyl. So I might say, oh, it's attached to the carbonyl carbon, or the carbonyl oxygen gets protonated. Or maybe I'm talking about the chemistry of the carbonyl pi bond, so I might draw attention to that. But we can use the term carbonyl to describe pieces of a molecule. And we can also reference the carbonyl as a whole. So in all of these functional groups, you're going to see that there is a carbonyl in the middle. And then what makes the functional group, specifically that functional group, is what's attached to that carbonyl carbon. So for something to be an aldehyde, you have to have a carbonyl, and then attached to the carbonyl carbon, there needs to be at least one hydrogen. So there is a specific aldehyde called formaldehyde that has 2 hydrogens attached to the carbonyl. This is just one specific molecule. It's the only example like this. Sorry, my pen is acting wonky, so let me see if I can draw that a little nicer. Oh, probably not. Okay. But most aldehydes will have a carbon on one side and then the hydrogen on the other. Again, it's this one hydrogen attached to the carbonyl that makes it an aldehyde. So another example could be something a little more complex, such as this. Our R group is this entire cyclohexyl group, and we haven't talked about cyclic alkanes yet, but we will get there. But what makes this an aldehyde is that you have a hydrogen attached to the carbonyl group. Our next one is the ketone, and what makes a ketone is that you have your carbonyl, and both things attached to the ketone have to be carbons. So a ketone is only a ketone if it has carbons attached to the carbonyl carbon. So this could be something as simple as acetone, or you can have things that are a little more complex, like cyclohexanone. Both of these feature a carbonyl. So here's your carbonyl carbon, and then it has carbons attached to the carbonyl carbon. Our last 3 functional groups also feature the carbonyl. So you'll notice they all have a carbonyl in the middle. And what makes these unique is for carboxylic acid, you will have a hydroxyl group attached to the carbonyl. So notice this is no longer an alcohol, and this is not a ketone, it's not an aldehyde. This situation where you have a carbonyl with an OH group attached to it is a carboxylic acid specifically. In our next one, we have what's called an alkoxyl group. So this is a combination name of alkyl and hydroxyl. So an alkoxyl group attached to the carbonyl makes an ester. And then for something to be an amide, notice I'm using short sounds for the A and the I. The word amide actually means something entirely different, even though it's spelled the same way, which is incredibly obnoxious, but there's nothing we can do about it. Amide with short sounds is when you have an amine attached to the carbonyl carbon. So all of these have an amine attached to the carbonyl carbon. So let's draw some examples of these. For carboxylic acid, you've actually seen a ton of these because we did acid-base chemistry in the last chapter. But acetic acid is a really common example. Or you might have something a little more complicated, such as benzoic acid, where you have a benzene ring on the other side. But again, the important thing is you have your carbonyl carbon and the hydroxyl group is attached to it. Esters can be really fun. You can have any number of carbons on the other side of the carbonyl. It would not matter. And then as long as you have an alkoxyl group attached to the carbonyl, this is an ester. So this piece is what makes this an ester. Esters can also be cyclic. This has a special name. It's called a lactone, but we'll worry about that. I think it's chapter 13 or 14 when we get to that. But as long as you have an alkoxyl group attached to that carbonyl, it is still an ester. And amides can look a lot like esters because you're going to see that you have that carbonyl and then you have some sort of amine attached to them. That amine could be something like NH2, or it could be a nitrogen that has carbons attached to it. So amides can be really fun. They can also be cyclic like the esters. And that's all of our functional groups.